right, here we are. Excuse me. Section 6.1, Chapter 6. 2 more chapters to go. In this lesson today, we're talking about rational exponents, meaning a rational exponent with the word ratio in it means I'm going to have a fraction in the exponent. So I'm going to have x to the 1/3 as an example. All right, then we got to learn how to convert that into a cube root problem, if you will, and we'll get to that. Right now, our objectives is to simplify radical expressions using the definition of roots. Okay, and the second one, B, is to simplify expressions with rational exponents. All right, so let's talk about square roots, basically. If I have something like and when we think about this, and this is on page 510 and 511, you may want to read that over a little bit because we have a little bit of problem when we start here. So if I have, I'm going to say the square root of x and it's squared, then I could have two possible answers. I could say that one, the positive square root of square root of x to the square is x. Okay, and then I could also say, what about the negative? Because isn't it true that, I'll come over here, a little sidebar, negative x times negative x equals x. And that would be negative x equals x squared as well. So I have two possible answers, one being positive and the other being negative, because the square root of x could be negative times a negative. But when we write that, we're going to say that if I have the square root of x squared, then it's possible I could have negative x squared as well. But we write that as with the negative on the outside. All right, if they want us to have a negative answer. All right, so if I have an example 1, they give us something like what is the positive square root of 64 is 8, because 8 is the positive number with the property 8 squared equals 64. So in other words, 64, the square root of 64 equals 8. And then if they wanted the negative, I'd have to write it as the negative square root of 64 equals negative 8. And that way it ensures that I have the negative 8 there with the answer. All right, you don't get too many of these, so I wouldn't overly worry about this type of problem. And a huge hint when you have numerical values, well, use your calculator too. You can use it to verify it. I'm going to go in here and act like we don't have the calculator. All right, just to kind of give you a lesson here and answer some questions here as we go. So example, our power practice problem 1, we have practice problem 1 here is going to be give the 2 square roots of 36. So here's the square root of 36. So one answer is going to be the positive square root of 36, which is just 6. And the other square root is negative 6. So I'm going to write that as the negative square root of 36. And then I'm going to get negative 6. Because negative 6 times negative 6 is positive 6. All right, so that's all we're talking about there for now. There's a nice chart here. I'll get into this mostly as we go with our examples. And let's start with roots and negatives. Example 2. Simplify each if possible. And let's see what we come up. And, again, we're allowed to use our calculator, so, let's use it. I can't stop that from happening. It's just what it is. All right, so let's see. I'm going to do the practice problems of 2 on number 2. So here I've got the first one is that the cube root? This is my index number now, and negative 64. All right, so let me kind of go with that right here, and then here I could have x to the, I'll just leave it at that. That's not important. All right, so this is the radicand. The x is the radicand. This number, that's the index number. That's what we call the index number. That tells you what root they want us to simplify for. All right. Most of the time, or many a times, it's just written without a number there. And it's presumed that we all know that it is the square root, meaning there's a 2 there, but not really written. Okay, and that's what that means. What is the square root of a number that would be inside, the square root of the radicand, in other words. All right? Any other number we'd have to write there. What's the third root, fourth root, fifth root, etc., etc. Okay, that tells you how many roots they want. Now, with a square root, our answer is always positive. When I go to the cube root, then I'm going to have 3 numbers that are negative to get me this solution for 64. So I'm going to look at that and say, what is the third root of negative 64? Okay, and I can break that down, the 64, and if I break that down using it's called the prime factorization. I urge you to do this for this chapter, or whenever we are needed to do it. It's really kind of fun, and you'll master your basic facts in multiplying if you need that. All right, so this is the third root of negative 64. I'm going to break the 64 down, and that's 8 times 8. And then the 8 I'm going to break down to be 4 times 2, and I'm circling my primes as I go. 2 is a prime number, and 4 I'm going to break down to be 2 times 2. 2 times 2. See if I can squeeze that in there. So then I've got 2 times 2 times 2 for this 8. Here's another 8, and I'm going to have the same thing without having to figure it out. That's another thing. You do these numbers over and over again. After a while, you're going to remember them. You'll just memorize them unintentionally. All right, these 2's are also. So what have I got? These 2's make up the 2 times 2 times 2 is 8 as well. So here I've got 6 2's. And now I'm going to rewrite this problem, and I'm going to say what they're asking for here is the cube root of 2 times 2 times 2 times 2 times 2 times 2. Okay? And there I go. That's my 8 times 8 is 64. The cube root is going to be for every 3 of the same numbers. This tells you how many of the same numbers I want to take out. For every 3 of the same numbers, I'm going to take 1 out. So here's 2 times 2 times 2. There's 3 2's there. I'm going to take 1 of those 2's out. And out of the radicand, out of the radical sign. And here's another set of 2's. So I got everything taken out from underneath the radical sign. And for every 3 2's, I'm going to take 1 out. Here's another one. So, evaluating this, I've got 2 times 2 is 4, and there's nothing left under the radical sign. So the cube root of 64 is 4. However, this was negative 64. So this 4 is going to be negative 4. Why? Because negative 4 times negative 4 times negative 4 is negative 64. Okay, it was the third root, negative, so I know all these numbers got to be negative. I've got an odd number of negatives, so my answer is going to be negative as well. All right, let's see another one. They've got a list there on page 512. Next one is the square root of negative 25. And what do we know about that? What can we say about it? It's negative. We cannot have a negative under the square root. I can have under the third root or the fifth root, or the 7th root, all the odd indexes, but not the square root, because I'm looking for two numbers that are the same that'll multiply to give me negative 25. And you can't do it. One's number's got to be negative, the other's got to be positive. So this one is going to be not real for right now. Okay, and then how about I've got negative on the outside, square root of 4. So this one, square root of 4 is 2, and the negative just comes along. So I got a negative 2 there. How about the cube root? Here's the cube root of negative 1. All right, well, what do we know about negative 1? So it's going to be negative 1 times negative 1 times negative 1. And I'm looking at it this way. The cube root of negative 1 is going to be, well, for every 3 of the same numbers, I'm taking 1 out. I've got 3 negative 1s, so I'm going to take 1 of the negative 1s out, and it equals negative 1. The cube root of negative 1 is negative 1. And one more where I've got the 4th root. 4th root of negative 16. Is that possible? It is not possible. It's not a real number because I'm looking for an even number of numbers that would give me negative 16. And again, that's like the square root. So the even numbers I cannot do, the odd numbers I can with respect to the negative along in the number that's under the radical sign. Okay, so beware of situations like this, but not of this nature here. This is okay, this is not. All right, let's see here. I'm going to go now to example 3, variables under a radical. All right, now I'm going to blow these things up so we can understand what's going on if they're asking us for the square root, the cube root, or even the 4th root. And again, sit back and enjoy. It's just kind of neat. Okay, and where shall I go here? I'm on power practice problem 3. And this one is practice problem 3. And this one I've got the square root of 81, a to the 4th, b to the 8th. A to the 4th, b to the 8th. And I got to look at this and say, what is this? All right. The square root of 81 is going to give us 9. It's like 3 times 3 times 3 times 3. And if this is a square root, then for every 2 of the same number, I take 1 out. So I'm gonna blow this whole thing up to give you a real example of what's going on here. So 81, first 2 numbers I think about is 9 times 9. Okay, and then I've got 4 A's, so it's A times A times A times A. And oh God, I got 8 B's. Well, me and my big mouth. B times B times B times B times B times B times B. How many is that? 1, 2, 3, 4, 5, 6, 7. And then times B. I'll squeeze it in at the end here. All right. So this is everything all blown up. And it's like saying, what is the square root of all this? It's saying the same thing. All right, so now my index is 2. Remember, it's not written when we have the square root. So that means for every 2 of the same number, I'm going to pull 1 out. For every 2 of the same number, I'm going to pull 1 out, or variable in this case. 2 9s, I'm going to take 1 out. I've got 2 A's here, I'm going to take 1 out. 2 more A's here, I'm going to take 1 out. I'm going to square that too. Same with the B's now. So 2 B's, it'll be times B. 2 B's here, and I'm just going to take 1 out, and I'll write it out here this way. Here's 2 more B's, take 1 out. And here's another 2 b's, I'm taking 1 out. So this b times b times b is now b to the 4th. So all this is going to equal 9a squared b to the 4th. Okay? And that's it for now. You'll see a shortcut here after a while where you can use division, but I'm not going to tell you that right now. I want you to kind of explore this and get the notion of what's going on, of deeper, richer understanding. Okay, next is a cube root. I'll be right back. Okay, so here again, now I want the cube root of 8x to the 3rd y to the 9th. So I'm going to explode up what's inside. So 8, I'll do some work over here. I'm going to bring this down. It's 2 times 4, and the 4 breaks down to be the 2 times 2. So we've done this 2 or 3 times already. So I'm going to remember that the cube root of 8 is 2, because I've got 3 2's. For this problem, I'm going to write it out. And I'm going to have, let's see, I'm going to have 2 times 2 times 2. The cube root, or 8, broken down, the prime factorization of 8 is 2 times 2 times 2. Now I got 3 x's, 3 x's, and then I've got 9 y's times y, 3, 4, 5, 6, 7, 8, 9. There. And this is what we're saying. What is the cube root? This index number is very important to write in our answer. So I've got the cube root of all this. And this is saying for every 3 of the same number, take 1 out. 3 2's, take 1 out. 3 x's, take 1 out. 3 y's, take 1 out. 3 y's again, take 1 out. And yet 3 y's again, take 1 out. So this ends up being the cube root of all that, 8x cubed y to the 9th equals this, 2x y to the 3rd. And that's my answer for it. Okay, isn't that kind of fun? Just a little bit. The next one is a 4th root. All right, same deal. Now I want the 4th root. So 81 I'll bring over here. That's 9 times 9. 9 breaks down to be 3 times 3. These are prime. And this 9 will break down to be 3 times 3. The beauty of breaking it down into your prime factorization numbers. All right, then I can handle the a to the 4th and b to the 8th. All right, so let's see. What am I going to have here? Let's see if I can. 4th root, right, of 80. No, not that. I already did that. This, 3 times 3 times 3 times 3. That's my 81. And then I'm going to have times A times A times A times A, and then times B times B, and I got to do this 8 times. There's 4. 1, 2, 3, 4. Okay, and let's extend this out, and there we go. Now I can get my answer. Now it's saying for every 4 of the same number, I'm going to take 1 out. And here's 4 3's, so 1 comes out. 4 A's, so 1 comes out. 4 B's, 1's coming out. And 4 B's here, 1 comes out, and I'm going to square this one. All right, and this is my solution. The 4th root of 81, a to the 4th, b to the 8th, is 3ab squared. And you will guarantee to get them right. Your calculator won't help you with the variables, but it will with the numerical values up to a point. And we'll show you that. Okay, so that was practice problem 3. And now let's go to rational numbers as exponents. Okay, what's a rational number as an exponent? Okay, I've got as an example when we're talking about rational numbers as exponents. So rational meaning the ratio, those are fractions that are used as exponents. And an example here is this 8 raised to the 1/3 now. And we haven't had that. But what does that mean? So for our sake of discussion, this is going to mean that this is the third root of 8 to the first power. Now, how do we look at how we're going to transform these problems into something more understandable? All right, so I took this is the exponent is 1/3. The denominator, the 3, comes out, and that is the index number. And the 1 remains as an exponent of the radicand. So this remains 8 to the first power. The numerator is going to be the exponent that remains with the radicand. All right, so this is the transformation we're making. Now I can say, what is the cube root of 8? The cube root of 8 is 2. We have figured that out a couple times. Okay. All right. So let's go to our examples in or power practice problems on number 4 on page 513. All right, let's just remember that, what happens, and we'll do an examples to reinforce that. So here is practice problem 4, and I'm going to have first is 9 1/2. So that's going to transform into the 9 is here. The exponent is 1/2, so the 2 comes out as the index number. We know that's the square root. And the 1 in the numerator of the fraction is going to be the power that the 9 is raised to. So this is simply saying, what's the square root of 9? And that's given us our 3. Okay, how about B, 27 to the 1/3? What does that equal? Well, let's try it. Here's my radical sign. The index number is 3. The 27 is here, raised to the first power. So that means, what's the cube root of 27? All right, I'll come over here, do my 27, break it down. What's two numbers that multiply to be 27? How about 9 times 3? 3 is prime. The 9 breaks down to be 3 times 3. And now this is going on to say, what is the cube root of 3 times 3 times 3? For every 3 of the same number, you take one out. There's 3 3s, I'm taking one out. And it's just going to equal the 3 that I took out. All right, there's nothing left under the radical sign. So the cube root of 27 is 3, or 27 to a third raised to the power of 1/3 equals the cube root of 27, that equals 3. Next up is, all right, here it is, our next problem. -49 raised to the 1/2. So this is an equivalent expression. It's going to be a negative radical sign. My index number is going to be 2, so I can leave that because it's a square root of 49. And this is going to end up being -7. The negative just comes along. All right, if I had the number in parentheses, however, if I had it as negative 49, this is specifically telling us that the base number is negative 49 raised to the 1/2 by the use of parentheses. So now this is going to end up being the square root. I can put the 2 there just for reassurance. And in the radical, I got negative 49. This is saying, what's the square root of negative 49? I have to put the negative underneath as the radicand, or underneath the radical sign, because that's what the parentheses are telling me what to do. All right, so this is going to be no answer because you can't have a square root of a negative number. Okay, and one more. One more is 16 over 25 in parentheses, and that's raised to the 1/2 as well. So now this one you can, if you like, separate it, and you could write this as the square root of 16 over the square root of 25. Ultimately, that's what happens. There's really a 1 here and 1 here. You would multiply that using the power rule, changing it to 16 raised to the 1/2 power and 25 to the 1/2 power. And that's what this ends up being, is the square root of 16 over the square root of 25, which is just 4 over 5. And there you're in good shape. All right, that was letter E. Yes, and let's see what else we got. All right, next what we want to do now is we want to review our properties of exponents. Okay, so I'll follow along in our book, or maybe I'll use my own variables here, but it's the same idea. So if I have a to the x times a to the y, then my answer for this is going to be a to the x plus y, where we add the exponents up together. Okay, that's the product rule. The power rule, I'm going to say a to the x raised to the y. Then we're allowed to multiply x, y, so my answer for this one's going to be a to the x, y, x times y. Okay. The distributive property for exponents is next, which is saying a b raised to the, say, x. Okay, and what's that going to mean? That's going to mean a to the x times b to the x. Definition is as such. All right, and you remember some of these other ones. A to the negative x equals 1 over a to the positive x. Remember, this is like a numerator, this is the denominator, and we flip the position that it's in. It's in the numerator, so if I bring it to the denominator, the exponent only turns positive, not the base number, not the a, just the exponent. Okay, fair enough. Then we've got something of the nature of a over b, and it's raised to the x power. So just like the one we had here for multiplication, this is one for division, and we treat it the same way. I'm going to distribute that to the exponents of the a and the b, the x. And same with this. There's really a 1 here and a 1 here. Because of the parentheses, that means, I'm going to use the power rule. And on a fraction, you distribute it to the numerator and denominator. So here you're going to have a to the x over b to the x. And whatever you get from that. Okay, use the quotient rule next, which is a to the x over same base, a to the y. And that could equal a to the x minus y. Remember doing that. Okay, and one more is what we just learned, which is a to the negative x. No, I take that back. I want my fraction here, and that's going to be a raised to the 1 over x, which is going to equal the square root, or the x root, of a to the first power. Okay, and you really don't need the 1 there as the exponent of a. Okay, so there's a review of all our properties, and now we got to use these with our rational exponents, which means we're back to fractions. Okay, so let's try it out. Practice problem 5, it looks like. All right, here's our first one, and our directions are to write each radical with a rational exponent and then simplify. Don't just take this and write the answer to it. They first want to see what does it look like with a rational exponent. And I guess we could do it this way and say, well, 3 is our index number. So I'm going to take what's inside. This is what's inside, x to the 6th, y to the 12th, and then put it in parentheses and raise it to, remember, our 3 came from the denominator in the fraction, and up top it's just going to be 1 because all this is raised to the first power. Okay, so this is how I would write it with a rational exponent. Taking what's inside, don't change that at all or deviate from it, and then my index number is going to be my denominator in the rational exponent. And that's it. Okay, now if we simplify this, now I can use the power rule to simplify this. And I'm going to say 1/3 times 6 is 2. So it's going to be x squared, and then y to the 1/3 times 12 is 4. So this is my solution for that particular problem. All right, so I got 2 xy to the 4th. And by golly, I think, oh, hold on a second. All right, here's practice problem 5. I, of course, did example 5. All right, so bad habit. All right, so here's a different problem, and I want to write this with a rational exponent. So I'm going to take what's inside. Notice how I'm putting it in parentheses and making it 8x cubed y to the 9th. And that's going to be in parentheses, and I'm going to raise that. The 3 is my index number. That's going to be my denominator, and what's going to be the numerator is 1, because this inside the radical is not raised to a power other than 1. There's really a 1 here. All right, and now this is my problem, and I'm going to distribute that. 8 could be, I could rewrite that is, well, the cube root of 8 is going to be 2. Okay, I'm just going to say it that way, like we have here. The cube root of 8 is 2. And then I'm going to have 1/3 times 3. And that's going to be x to the 3 over 3, which is just x to the 1. And then I've got 1/3 times 9, which is 3, and that's going to give me y to the 3rd. And that's my simplification of practice problem 5. Here's written with the exponent, and then I simplified it to be right here. Not bad. All right, we got one more to go here. And here it is. So let's write it with the rational exponent. And then by taking what's inside, 81, a to the 4th, b to the 8th, and all that is going to be raised to the 1/4 power. Okay, then I could say, what's the 4th root of 81? Because really I could rewrite this to be 3 to the 4th power. And then, so my 4th root of 81 is going to be 3. So let's write the 3 down. Then I'm going to distribute the 1/4 to the 4 here. 1/4 times 4 is 1, so a to the 1st power is a. And then 1/4 times 8 is going to be 2. 1/4 times 8 is 2. So it's going to be b to the 2nd power. And that's what I've got. 3ab squared. And we're done with that. Remember, your question is going to be write this with a rational exponent, which my answer is going to be here. Then we're simplifying it. Okay? All right, now we're going to simplify them directly from the rational exponents. All right, so now I'm going to have 8 2/3. 8 raised to the 2/3 power. Now, I don't have any idea. So I want to break it up into something that I know. So let's see, this is going to end up being, they're asking what is the 3rd root. The 3 is the index number, so that's going to come here, of 8. And you can put that in your parentheses and then raise it to the 2nd power. And this is what they're asking. What is the cube root of 8 squared? Or you could do, what is the cube root of 8 and then square it. Okay, so let's try it. That's the way I like to do it. Take the smaller numbers because they're easier to work with. So this would be like saying, what's the cube root of 8, which is the square root of, or the cube root of 2. And that 2 is going to be raised to the 3rd power. And what else? Then all this raised to the 2nd power. Did I mess that up? Well, I'm answering it is first of all what I'm doing. So this is going to simplify to be 2 to the 2nd power. Okay, and this is like the square root of that. But ultimately then oops, I did it again. I'm doing the example. So ultimately this ends up being 4. Because this is 8 squared is 64. All right, so I don't need that there. I'll do another one here. Okay, let me go back. I got shook up because I did not do the practice problem. I did the example. So this ends up being 2 squared, and which equals 4. But the easier version of that is looking at that as saying 8 to the 2nd power is 64. The cube root of 64 is 4, because 4 times 4 times 4 is 64. Okay, and you'll do the same thing. You'll look at it and say, I'm going to do this a little easier way that you're accustomed to. Let's try this one. I'm going to have 9 to the 3 over 2. Now that's going to end up reading, what is the square root, I can put the 2 there, of 9 raised to the 3rd power. Okay, now I can look at this and say that, well, the square root of 9 is 3. Then I've got 3 to the 3rd power. And 3 to the 3rd power is going to give me, and 3 to the 3rd power is going to give me 27. And that's the simplification of this. And again, this is like saying, what's the square root of 9 times 9 times 9. 81 times 9, 729. If you plug this in your calculator, you should end up getting 27. Square root of 729 is 27. So we got a match, and we're good with that. Here's another one. Remember, we're just simplifying. So I'm going to read this and write it as the fourth root of 16 raised to the third power. That's what we're doing. Okay, the fourth root of 16, well, I'll help you figure it out. 16, the fourth root of 16, so I want to break the 16 down to be 8 times 2. 2 is prime. The 8s I know are 2 times 2 times 2. There's my 3 2's on the left side. So this is saying, what is the fourth root of 2 times 2 times 2 times 2? And it's just going to be 2. And then we raise that to the third power. That gives us 8. This third power here is what I'm talking. First, we figured out what's the fourth root of 16, and then raise it to the third power. Well, now we have a negative exponent, so I can handle it just the way it is, because I'm going to rewrite it with the radical sign to be the third root of 8 raised to the negative 2, like so. And now I'm going to take, what is the third root of 8? We know that to be 2, which is 2 raised to the negative 2. And then when I simplify this, it's going to be what? 2 raised to the negative 2 is the same as saying what's 1 over 2 to the positive 2. Or I'm changing that negative exponent to positive by bringing it from the numerator to the denominator. And there I've done that here, and 1 over 2 raised to the 2 is 1 over 4. And that's good. Okay, one more. Okay, again, here's my problem. So now this is going to be the fourth root of 16 over 81, and then raised to the negative 3. All right, what's the fourth root of 16 over 81? The fourth root of 16 is going to be 2, and the fourth root of 81 is 3, and that's going to be raised to the negative 3. Okay, so let's see. I'm going to rewrite it over here. 2 over 3 raised to the negative 3. And now I can use the power rule and distribute the negative 3 to the exponents on the fraction 2 over 3. All right, so this is going to look like 2 raised to the negative 3 over 3 raised to the negative 3. And now I want to get these to be positive, so I'm going to flip them, and this is going to be 3 to the third power over 2 to the third power. Okay, and now I can just figure out what is 3 to the third power, which is 27, over 2 to the third power, which is 8. So this breaks down and ends up being 27 over 8. Okay, so we're just simplifying these from the rational exponents, not from the index numbers or the cube roots or any other roots, really. All right, let's do one more example in practice problems in number 7. Okay, in this section we're practicing our properties of exponents. And we have these rational exponents, but we know how to multiply and add fractions and the like. All right, so this is x to the 1/2 times x to the 1/4. So that means, what's that property tell us to do? X to the 1/2 plus 1/4. Okay, so we're going to add our two fractions up. So it gets our denominators to be the same, you know that routine. So I'm going to end up having 2 times 1 is 2 plus 1 is 3 over my denominator is 4. So this is going to end up equaling x to the 3 over 4. Remember not to put your answer as 3 over 4, but it's x to the 3 over 4. All right, so there's our first one. Our next problem, B, is going to be, let me write it up first. Okay, so here we've got the power rule. All right, and let's do the power rule. So the power rule means we can multiply these two fractions. Okay, so that means it's going to be y to the 3 over 5 times 5 over 6. Okay, and that's going to end up equaling what? We're multiplying these, so let's cancel whatever we can. So the 5's can cancel out, become 1's. Then I got 3 goes into 3 once, and 3 goes into 6 twice. So this all ends up being y to the 1/2. Okay, not bad. All right, here's the problem C in practice problem 7. So my bases are the same in fraction form, so now I'm going to use the quotient rule. And I subtract one fraction from the other. And ideally, you want to subtract the smaller fraction from the larger one. All right, so this is going to be 3/4. This is going to read, it equals z to the 3/4 minus 2/3. Okay? So let's get our denominators the same. The 4, I'm going to multiply top and bottom by 3. That'll be 3 over 3. And the 3, I'm going to multiply by 4 top and bottom. This is subtraction, so I know my denominator is 12, and my numerator then is going to be 3 times 3 is 9, minus 2 times 4 is 8, 9 minus 8 is 1. So my answer is going to be z to the 1 over 12. Let's do D. Okay, here's D. And again, we're going to distribute the 4 to the exponents on the inside of the parentheses. So this is going to end up being a to the 4 times 3 is 12. 12 divided by 4 is 3. A to the third over b to the -2. 4 times -1 is -4. -4 divided by 2 is -2. We cannot have the negative exponent. I got to change it to positive, so it's just going to come upstairs and join the a to the third. So it's going to be a cubed b to the square. And this is my solution for that one. Okay, and one more to go. All right, here's the last one, I believe, of the do for sure. Last one of the section. And on this one, let's just do some distributing first. So here I've got this 6, I'm multiplying it to 1/3, and that's going to give me x squared. 6 times -3 is -18. That's going to be y to the -18. And that's going to be over this x to the 4th and y to the 10. And notice we are not distributing that 6 to this denominator, because it's not the same as saying a over b, raised to the x power. When it's this situation here, I distribute the exponent to the a to the first power and b to the first power. Then I would, but I don't have, this isn't all enclosed in parentheses. Just the numerator is enclosed in parentheses. So we want to be careful of that. Do not fall for it. What we have here is the idea that I got to simplify this. And what is it? Always subtract the smaller exponent from the larger one. So in this case here, I'm going to see if I can squeeze that in. X squared divided by x to the fourth, well, that's 4 minus 2, and I'm doing that in the denominator. That's going to give me x squared. Okay, then I've got 10 minus negative 18. Or if I wanted to do to the top, it would be negative 18 minus 10. I will, just because the arithmetic's a little easier. So y to the negative 18 minus 10 is going to give me y to the negative 28. And again, I can't have a negative exponent in my answer. I don't know why, but you just can't. It's a rule. All right, so I'm going to bring that down below. So it's going to end up being, since there's nothing in the numerator, I have to have something, so that's where the 1 comes in. I have to have that up top. And then my final answer will be x squared y to the positive 28. And now I've got it done and I'm complete with that. So there you go. That's section 6.1. And it shouldn't be a problem. I don't anticipate it being a problem. I do not. All right. Take care. Have a good day.